When a modern commercial airliner docks at a gate, the clock immediately starts ticking. Ground crews, refueling trucks, and baggage handlers swarm the tarmac in a heavily choreographed sprint where every second dictates the flight's profitability. This chart shows the mathematical wall facing the industry. In 2024, passenger volume hit 5.3 billion, and that number is projected to double by 2040. Yet, as the bottom line shows, physical airport footprints are remaining stagnant. We have reached the limit of physical expansion. Surrounding cities, environmental regulations, and massive capital costs mean aviation hubs can no longer solve capacity issues by pouring more concrete for new runways and megaterminals. When physical space is capped, minor timing errors become catastrophic. A delayed bag, a missed security scan, or a late tug on the tarmac cascades through the entire network, turning localized hiccups into massive financial losses and terminal-wide queues. To maintain growth, operators are shifting to a new operational paradigm, virtual capacity. This approach uses hyper-automated digital workflows and real-time data orchestration to optimize every inch of existing infrastructure. Aviation hubs can decouple throughput growth from physical real estate by utilizing these digital tools to accelerate aircraft turnarounds and eliminate terminal bottlenecks. That acceleration begins the moment a traveler enters the building. Traditionally, the passenger journey required presenting physical documents, passports, boarding passes, and visas, at half a dozen disjointed checkpoints. These physical choke points are being replaced by a tokenized digital identity. A traveler's verifiable credentials connect directly to their biometric profile, allowing them to move through the airport without reaching into their pocket. This is already live at hubs like Miami and Dubai. High-resolution biometric facial recognition systems actively process passengers, matching their live face against secure government-issued documents in seconds. These systems reduce transaction times to roughly 3 seconds, clearing massive queues instantly, dramatically increasing the total number of passengers a terminal can handle per hour. Shifting to digital verification also improves border security. By delegating document review to automated systems, agents can focus their attention on proactive, data-driven threat assessment rather than manual bottleneck management. Tokenizing the passenger changes the nature of the terminal, converting it from a series of static holding pens into a fluid, frictionless transit corridor. But the terminal is only one piece of the puzzle. The most fragile links in the chain are the hidden logistics occurring in the baggage halls and on the tarmac. Efficient airports have stopped viewing baggage systems as simple, static conveyor belts. Instead, they are managing these systems as live, responsive operating networks. This requires agentic AI. Unlike basic analytics, agentic AI autonomously triggers real-world actions, like rerouting luggage around a conveyor jam or dispatching a cleaning crew without waiting for human intervention. At Singapore's Changi Airport, this automation is physical. They have deployed a fleet of autonomous baggage tractors to navigate the tarmac and transport luggage directly to the aircraft. These autonomous units navigate crowded, complex ramps safely. They maintain a consistent pace during severe weather or peak hours, reducing the likelihood of human-induced delays during the turnaround. Extending intelligent automation to physical ground operations secures the aircraft turnaround chain against the variable delays of manual labor. Governing the data generated by the terminal and tarmac requires a centralized nervous system called Airport Collaborative Decision-Making. This unified layer fuses disparate flight, security, and baggage systems into one operational picture, building a predictive blueprint of the hub. Real-time data orchestration creates the true strategic advantage of virtual capacity, anticipating and neutralizing physical bottlenecks before queues ever form. Digitizing physical infrastructure at this scale creates entirely new categories of systemic liability. This chart visualizing facial recognition performance shows the risk of algorithmic bias. NIST evaluations indicate that false positive match rates can be 10 to 100 times higher for certain demographic groups. This bias has real operational costs. False negatives lead to unequal treatment, wrongful security scrutiny, and processing delays that target specific passengers. Housing permanent biometric templates also creates a massive cybersecurity risk. Operators must implement strict data deletion protocols and conduct rigorous data protection impact assessments to ensure traveler data is not retained beyond the flight. As airports achieve virtual capacity, their primary operational risk moves from the terminal floor to the data center, where vulnerability and civil liberties compliance become the new security priority. Successfully deploying predictive AI and biometric tracking requires leadership to rethink the entire operational workflow, from passenger arrival to aircraft takeoff. This transition requires a rigid governance framework. To maintain public trust, leaders must prioritize algorithmic transparency, human oversight, and absolute data integrity. The ability to transition from conceptual insight to responsible, scaled execution is the threshold that will separate legacy operators from the true innovators of the next decade.